Hi everyone, I am Dr. A. Rushi Kesava, Associate Professor of Mathematics, Department of Freshman Engineering, Marri Laxman Reddy Institute of Technology and Management, Hyderabad. So today we discussed first year, first BTech matrices and calculus in the subjects Unit 2. This is the contents of the Unit 2. So the introduction of the eigenvalues and eigenvectors, properties of eigenvalues and eigenvectors, Cayley-Hamilton theorem to using the Cayley-Hamilton theorem to find the inverse of the given matrix and power of the matrix, and diagonalization of a matrices and quadratic forms, and reduction of the quadratic forms to canonical forms by using orthogonal transformations. Okay. So now we discuss the definition of the eigenvalue and eigenvector. Basically, the eigenvalues and eigenvectors are using only in a square matrix. Okay, let A be a square matrix. A is be a n into n matrix. A non-zero vector capital X is said to be characteristic vector of A if there exists a scalar lambda such that Ax equal to lambda x. If Ax equal to lambda x, we say that X is a eigenvector or characteristic vector of the matrix and corresponding to the eigenvalue or characteristic value lambda of the matrix A. So, now the characteristic matrix defined by A minus lambda I. The characteristic matrix is denoted by A minus lambda I and is defined by A11 minus lambda, A12, A13 and so on. So, okay, example here, A is any matrix, A11, A12 and so on, A1n, A21, A22 and so on, A2n, like this, an1, an2 and so on, an into n. It is a square matrix. So, the characteristic matrix defined by A minus lambda I, that equal to A of the matrix A11, A12 and so on, A1n, A21, A22 and so on, A2n, like this, an1, an2 and so on, an into n minus of lambda is a scalar into I is the identity matrix 1 0 dash dash 0 0 1 dash dash 0 0 0 dash dash 1. So the matrix after subtracting the scalar lambda and identity matrix, the entire matrix shown in the figure A11 minus lambda like this, A21 dash A22 minus lambda and so on like this, an1, an2 and so on, ann minus lambda like this. So finally this is the output of the characteristic matrix. Okay. Next, so now coming to the characteristic equation, the characteristic matrix. So we can write the characteristic equation means the determinant of the characteristic matrix, that is modulus of A minus lambda I equal to 0. That is the characteristic of the matrix. Using the characteristic matrix, we can find the eigenvalues of the given matrix. The eigenvalues also roots of the characteristic equation. The roots of the characteristic equation are the characteristic roots of the eigenvalues or latent roots also. Okay. So the eigenvalues also called as characteristic roots and latent roots. And if there exists a non-zero vector x such that Ax equal to lambda x, the corresponding to the eigenvalue lambda, and the non-zero vector x is known as the eigenvector. So the characteristic of the matrix, you can write Ax equal to lambda x. This is the definition of the eigenvalues. So here we can say that Ax equal to lambda I into x. I is the identity matrix. Just multiply the identity matrix. There is no changes in the given matrix. Okay. And take Ax minus lambda Ix equal to 0. Take left side of the right side of the matrix. And you can also write take x into a minus lambda I equal to 0. That means a minus lambda I into x equal to 0. Okay. Here A is the given matrix and lambda is the eigenvalue of the given matrix and capital X is the corresponding eigenvector of the given matrix. Okay. This is the formation of the eigenvalues and eigenvectors. And we now discussed some few properties of the eigenvalues. That is the important eigenvalues. Okay. So if here if A is a n into n matrix, we can have n times of the eigenvalues. So lambda 1, lambda 2, lambda n. Lambda n are the n eigenvalues. Then sum of the eigenvalues are trace of the matrix. Also product of the eigenvalues are determinant of the matrix. It is equal to determinant of the matrix. Example we see that let us take any matrix 1, 2, 0, 4. It is the 2 by 2 square matrix. So the eigenvalues of the matrix are 1, 4. Okay. Generally the eigenvalues of the matrix is 1, 4. So sum of the eigenvalues are lambda 1 plus lambda 2, that means 1 plus 4 equal to 5. It is trace of the matrix. Trace is 1 plus 4. That is the trace of the matrix. So sum of the eigenvalues are equal to the trace of the matrix. It is also product of the eigenvalues. So 1 into 4, 4. Determinant of the, it is equal to determinant of the matrix. So find the determinant of the matrix is given the matrix 1, 2, 0, 4, AD minus BC. So 4 minus 0, that equal to 4. So lambda 1 into lambda 2 is equal to det of A. So the product of the eigenvalues are equal to the determinant of the matrix. That is the main important of the properties in eigenvalues. So sum of the eigenvalues are equal to trace of the matrix and also product of the eigenvalues are equal to determinant of the given matrix. And the second one is lambda is the eigenvalue of the matrix A corresponding to the eigenvector x. Then in case lambda power n is also eigenvalue of the given matrix A power n with corresponding eigenvector x. Okay. So we can also take any example. For example, A is any matrix 3, 4, 0, 2. 3, 4, 0, 2. Here eigenvalues are 3, 2. The given matrix have a eigenvalues of 3, 2. Now the eigenvalues of the matrix A cube, I think A cube are the eigenvalues of the matrix A cube are lambda equal to 3 cube, 2 cube. That means 3 cube, 27 and 8. Okay. So here the eigenvalues of the given matrix A is 2, 3. The eigenvalues of the matrix A cube is 8, 27. That is lambda power n is the eigenvalue of the given matrix A power n. So we can also find the powers of the matrix also, find the eigenvalues. It is easy to find out given property using the given properties. Okay. Next, a square matrix A, its transpose matrix A power t have the same eigenvalues. So if you take any matrix, the eigenvalues of the transpose matrix also same, equal. Example, 1025. Take any matrix 1025. The eigenvalues of the matrix are 1 comma 5. Definitely surely the eigenvalues are 1 comma 5. Now the transpose of the matrix is a power t equal to 1205. The eigenvalues of the transpose matrix also same, that is 1 comma 5. So any matrix and transpose matrix, same matrix are same eigenvalues. That is the property of the given. Okay, eigenvalues. And the last one is some important. Here, if lambda is the eigenvalue of a non-singular matrix A corresponding to the eigenvector x, then lambda inverse is also eigenvalue of the matrix A inverse with corresponding eigenvectors x. Eigenvectors are same. Okay, itself. So here also take one example, that is 2 by 2 matrix 3508. 3508. Let us take any matrix A equal to 3508. The eigenvalues are of the given matrix is 3 comma 8. Okay, 3 comma 8. And the inverse of the matrix, having the eigenvectors are 3 inverse means 1 by 3, 1 by 3 comma 1 by 8. Lambda inverse means 1 by lambda. So the eigenvalues of the inverse of the matrix is 1 by 3 comma 1 by 8. These are the most important of the properties in the eigenvalues. Okay. Now we discussed some problems. Find the eigenvalues and eigenvectors. Okay. Here find the eigenvalues and eigenvectors of the matrix. Okay. So okay, write down. Let us assume that given matrix, let A equal to 5 minus 2 0 minus 2 6 2 0 2 7. It is the given matrix. Okay. So before you have to find the eigenvalues, first we have to write the characteristic equation of the given matrix. Okay. So now the characteristic of the matrix A is det of A minus lambda I equal to 0. That is the characteristic of the, we can write the characteristic of the given matrix. Okay. That means, okay, that is, so det of A minus lambda I means the scalar value lambda is subtract the given matrix in the diagonal form. Only diagonal values are subtraction of the scalar value lambda. Okay. So that is, we can write 5 minus lambda minus 2 0 minus 2 6 minus lambda 2 0 2 7 minus lambda equal to 0. Now find the roots of the matrix. Okay, already det equal to 0. So solving this above, we will get the eigenvalues, that is the roots of the given equation. Okay, first of all, characteristic equation, we have to find the characteristic equation. After that, using some scientific calculator or synthetic division, have the we have to find easily find the eigenvalues. That is the roots of the equation is the eigenvalues. Okay. So now solving this determinant. Okay. 5 minus lambda into AD minus BC. 6 minus lambda into 7 minus lambda minus 4 minus plus 2 into minus 2 into 7 minus lambda and 2 into 0 0, last one also 0 equal to 0. And solving the equation, 5 minus lambda into 6 minus lambda into 7 minus lambda, 42 minus minus 6 lambda minus 7 lambda minus 13 lambda plus lambda square plus 2 into minus 2 into 7 minus lambda. So that is minus 14 minus into minus plus 2 lambda equal to 0. Okay. Again solving it. 5 minus lambda into lambda square minus 13 lambda 13 lambda plus 42 minus 28 plus 4 lambda equal to 0. Okay. We can also write multiply by 5. 5 lambda square 13 5s are 65 lambda 42 into 5 is plus 210 and minus lambda cubed plus 13 lambda square minus 42 lambda minus 28 plus 4 lambda equal to 0. Okay. Again simplification of this term. Here lambda cubes are 1 minus lambda cube and lambda squares are 5 lambda square minus 5 lambda square plus 13 lambda square 5 plus 13 18 plus 18 lambda square and there is no lambdas. Next lambda values minus 65 and minus 42 plus 4 lambda. Minus 65 minus 42 that is 107 minus 107. Okay. Minus 107 lambda and constants are 210 and minus 28 plus 4 lambda. No 107 plus 4 lambda. That is 103. Yeah. Okay. This is 103 lambda and the constants are 210 minus 28. 210 minus 28 means 18. 182. Okay, 182. Okay, plus 182 equal to 0. So multiply by minus lambda cube minus 18 lambda square plus 103 lambda minus 182 equal to 0. So these are the characteristic equation of the given matrix. So now find the roots of the cubic equation. So it is also easy to find by using synthetic division or any scientific calculator. So I thought that the eigenvalues of this given equation, given matrix is, I think 3, 6, 9. It is easy to find out using the scientific calculator or any synthetic division method. Okay. So the eigenvalues are 3, 6, 9. Okay. So therefore, so already okay, we have done with eigenvalues. Now find the eigenvectors of the corresponding eigenvalues. Okay. Now the first one. Okay. Eigenvector of lambda equal to 3. Eigenvalue 3. Okay. Now find the eigenvector of the eigenvalue 3. Okay. So find the eigenvector, we can write the system of the equation, system of the matrix. Okay. Let consider the system is A minus lambda I into x equal to 0. Okay. The matrix of A minus lambda I into x equal to 0. That is, we can write the matrix is 5 minus 2 0. 5 minus 2 0, that is 5 minus lambda 2 0 minus 2 6 2 minus 2 6 minus lambda 2 and 0 to 7 0 to 7 0 to 7 minus lambda, and the vector eigenvector we can just write x1 x2 x3. Right side is 0 vector, 0 column vector. Okay, this is the system of the equation. Okay, now first eigenvector of the eigenvalue lambda equal to 3. Substitute the eigenvalue lambda equal to 3 in the system. Okay, so after substitute, put lambda equal to 3, we have okay. Let us write the system. 5 minus 3 means 2 0 minus 2, 6 minus 3 is 3 2 0 2, 7 minus 3 is 4. Okay, just write the only matrix. Okay, A minus lambda of the matrix. Okay, solving this matrix, we can find the eigenvectors of the given eigenvalue lambda equal to 3. So then we can use echelon form. Okay, solving the system is by using echelon form. That means already this one is 0. Okay, now second row, the diagonal values below of the diagonal values will be 0. Okay, that is the eigen echelon form of the procedure. Okay, now so this one take to 0 means using by using row transformation, R2 implies R2 plus R1. Okay, R2 plus R1, therefore 2 2 0, R1 plus R2 0, 2 plus 3 5, 0 plus 2 2, and 0 2 4. This is as it is. Okay, again one of the value 2 also. Okay, now we have to 0 the this one 2. So by using row transformation, okay, I applying R3 row transformation. R3 we have to make 0 this one. R3 make to this value will be 0. We are going to 0 this one. So by using the row transformation, okay. So R3 minus 2 R2. Applying the row transformation, R3 minus 2 R2. Okay, multiply by the second row by 2 and subtracting in R3 and row 3. Okay, third row. So after this one applying, we have to get 2 2 0 0 1 2 0. This will be minus 2 plus 2 0, minus 4 plus 4 also 0. So after applying echelon form, you have to get the matrix 2 2 0 0 1 2 0 0 0. The last row is 0. Definitely this last row is 0, because this you know the characteristic equation determinant of A minus lambda I equal to 0. That means A minus lambda is a non-singular. It is a singular matrix. A minus lambda, det of A minus lambda I equal to 0 means it is a singular matrix. Definitely the rank of the matrix is minus 1. Number of rows to minus 1. Okay. So less than of the number of rows also. Okay. So the rank of the matrix is 2. Number of variables are 3. Okay. Therefore, the rank of the matrix is 2. Number of variables are x1, x2, x3. That is 3. So the number of linear independent solutions are n minus r, 3 minus 2. That equal to 1 linear independent solutions is exist. So okay. So okay. Now write the system of the equations are 2x1 plus 2x2 equal to 0, x2 plus 2x3 equal to 0. Okay. So this is the after applying echelon form, this is the equations of the given matrix. Here one linear independent solutions are existed. Okay, so let us take that one. Let x3 equal to k, that is the linear independent solution. Let x3 equal to k. Okay, substitute this equations. Okay, x2 plus 2k equal to 0, that means that implies x2 equal to minus 2k. Okay, x3 equal to k and x2 equal to minus 2. This x3 and x2 are substituted in the first equation. Okay, we get x1 value. Therefore, 2x1 plus 2x2 equal to 0. After substitute x2, x2 are minus 2. 2 into minus 2, minus 4k equal to 0. That implies 2x2 equal to 4k. 2 ones are 2 twos are x2 equal to 2k. Okay, x3. No, x1. Yeah, sorry, this is x1. This is x1. Okay, x2 equal to minus 2k, x3 equal to k, x1 equal to 2k. Therefore, the characteristic equation, the eigenvector of the corresponding eigenvalue, we can write x equal to x1, x2, x3. That is x1 equal to 2k, x2 equal to minus 2k, x3 equal to k. Take k as a common factor of the given column matrix. That is 2 minus 2, 1. Therefore, the eigenvector of the given eigenvalue lambda equal to 3 equal to, that is x1 equal to 2 comma minus 2 comma 1. These are the eigenvector of the eigenvalue lambda equal to 3. Next, coming to, we have to find eigenvector of the eigenvalue 3. Next, the second one is, we have to find eigenvector of the eigenvalue lambda equal to 6. Okay, 6. That is second one. Eigenvector of corresponding eigenvalue 6. Okay, 6. Consider the matrix. Let us consider matrix of A minus lambda I into matrix capital X equal to 0. Okay, A minus lambda I. Okay, so write the system is A minus lambda I is 5 minus lambda minus 2, 0. 5 minus lambda minus 2, 0. Minus 2, 6 minus lambda 2. Minus 2, 6 minus lambda 2. 0, 2, 7 minus lambda. 0, 2. The vector capital X equal to x1, x2, x3. On the right side is 0. That is a homogeneous equation type. Okay. So 5 minus lambda minus 2, 0. And minus 2, 6 minus lambda 2, minus 2, 0, 2, 7 minus lambda. Okay. So these are the characteristic matrix A minus lambda I into x equal to 0. Now substitute lambda equal to 6. We have to find the corresponding eigenvector. Okay. Put lambda equal to 6 in the above equation. Okay. In the equation we have, okay, substitute. 5 minus 6 is minus 1, minus 2, 0. Here minus 2, 6 minus 6, 0, 2, and 0, 2. 7 minus 6 is 1. Okay. Okay. Just write the only A minus lambda I matrix only. Okay. So after using echelon form, that means using the row transformation, convert into echelon form. So we can easily solve the system of the given equation to find the eigenvectors. Eigenvector capital X, that means x1, x2, x3. Okay. So by using row transformation, here already -1, -2. So multiply by 2 in first row and subtracting second row. Okay. So that means R2 implies R2 minus 2R1. Okay. That is, we will get -1, -2, 0. R2 minus 2R multiply by row 1 by -2. Okay. -2 plus 2 minus 2, 0. And -2 into 4. Next 0, -2 into 0, 0. 2 plus 0 is 2. And the last one is 0, 2, 1. Okay. So again applying row transformation in row 3, we have to make 0 of the element 2. Okay. So applying R3 implies multiply by 2 in row 3. Okay. Third row. 2R3 minus R2. Okay. Minus R2. Okay. So we have to get the matrix -1, -2, 0, 0, 4, 2. And last one is 0. Multiply by 2. 2 2s are 4. 4 minus 4, 0. 2 minus 2, 0. 0 also. So last one is a 0 because the given matrix is singular matrix. Determinant of the characteristic equation equal to 0. That means singular matrix. Definitely the rank of the matrix is less than of the number of rows. Okay. So here the rank of the matrix are 2. Okay. Okay. Now the system of the equations we can write -x1 minus 2x2 equal to 0. And second one is 4x2 plus 2x3 equal to 0. These are the equations. Okay. Solving the above equation. Here 3 variables are 3, equations are 2. Okay. So that means we can write here the rank of the matrix is after applying echelon form R equal to 2. Number of variables are 3. So the number of linear independent solutions are n minus R equal to 3 minus 2, 1. That is 1 linear independent solutions. We can assume that same as it is x3 equal to k. Okay. x3 equal to k. So okay, substitute the value x3 equal to k into the given equations. Okay. First one, write down 4x2 plus 2k, 2x3, x3 equal to k, 2k. That implies 4x2 equal to minus 2k. 2 1s are 2 2s are. That is simply to write x2 equal to minus k by 2. Okay, x3 equal to k. Let us assume x3 equal to k is a linear independent solution. Can find x2 equal to k by 2. Okay. After using this one to find the x1 variable. Okay, x1. The first equation is minus x1 minus 2x2 equal to 0. Okay. Substitute x2 value and we will get easily x1. Okay. Minus x1 minus 2 into x2 is minus k by 2. K by 2 equals 2 cancel. Minus x1 minus plus k equal to 0. x1 equal to minus k here. Okay. The values are x1 equal to minus k. Therefore, x1 equal to minus k, x2 equal to minus k by 2, x3 also k. Okay. Therefore, the characteristic vector, we can write x equal to x1, x2, x3. Okay. Substitute the values. X1 equal to minus k, x2 equal to minus k by 2, x3 equal to k. Okay. So after simplifying, take k by 2 as a common in the matrix, column matrix. Okay. Because we cannot say factors in the eigenvector. Okay. Just common to k by 2. Okay. You cannot show. K by 2 means minus 2, minus 1. This is k by 2 means 2. So, okay, k minus k by 2, 2 to cancel, minus k. Okay, these are the, okay. So, don't have any fractions in the eigenvector. Okay, that's why we can take k by 2 as a common in the matrix. Okay, so this is the eigenvector. Okay, so the eigenvector of the corresponding eigenvalue lambda equal to 6 is, we can say that x2. x2 is minus 2, minus 1, 2. Basically, the eigenvectors are not unique. Okay, so different eigenvalues, different values. Eigenvectors are different values are there. Let us take k equal to 1, 2, 3, and so on. We can make the different eigenvalues, eigenvectors of the same eigenvalue. Okay, so always eigenvalues are unique, but eigenvectors are not unique. Okay, yes, it is a infinite solutions. Okay, so finally, the eigenvector minus 2, minus 1, 2 are the corresponding eigenvalue lambda equal to 6. Okay, so already we done lambda equal to 3 and lambda equal to 6. Now to find the eigenvector of the eigenvalue 6, last one. Okay, last one. Eigenvector of the eigenvalue 9. Eigenvalue of the eigenvector 9. Okay. So now same thing, write the corresponding matrix. Okay. So A minus lambda I matrix, consider the system. 5 minus lambda minus 2, 0. 5 minus lambda minus 2, 0. Minus 2, 6 minus lambda 2. Minus 2, 6 minus lambda 2. Okay. Minus 2, 6 minus lambda 2, 0 to 7 minus lambda. 0 to 7 minus lambda, and the eigenvectors are x1, x2, x3. Right side is 0, 0, 0. This is a homogeneous equation. Okay. So this is the consider of the system. So now substitute lambda equal to 9. Okay. Put lambda equal to 9. Then write the given matrix A minus lambda I. Okay. Substitute the lambda equal to 9. So we get 5 minus lambda, lambda equal to 9. 5 minus 9 is minus 4, minus 2, 0, and minus 2. 6 minus 9 is minus 3, 2, 0, 2. 7 minus 9 means minus 2. Okay. These are the matrix after substitute lambda equal to 9. Okay. So to solve this system of the matrix by using echelon form, convert into echelon form, that means applying row transformation. Okay. So already row 2 is minus 2. We make to second row first element 0. Okay. Minus 2 will be 0. That means multiply by 2, second row by 2, and subtracting the row 1. Okay. Applying row transformation R2. R2 implies 2 times R2 minus R1. Okay, that is. Therefore, we get minus 4, first row is same, minus 2, 0. Second row is minus 2. Second row applying 2R2, 2R2 minus R1. So minus 4 plus 4, 0. Next, 2 into minus 3, minus 6. Minus 6 plus 2. Minus 6 plus 2, minus 4. Next, 2 2s are 4. 4 is the only value. Getting the value only 4. 0 2 minus 2 in third row. Okay. After applying the row transformation, we have to get the matrix. Again, applying row transformation in R3, we make it 2 as 0. Okay. Again, so row transformation R3 implies multiply by R3 2. 2R3 plus R2. Okay. Row transformation. So we will get minus 4, minus 2, 0, 0, minus 4, 4. You can easily 0. 2 2s are 4. 4 minus 4, 0. And minus 4 plus 4 also 0. Okay. So definitely last row is must be 0 because it is a singular matrix. Okay. Okay. The system of equations are, write down the system of equations are minus 4x1 minus 2x2 equal to 0. And second row is minus 4x2 plus 4x3 equal to 0. Okay, solving the equations, we have to get x1, x2, x3. But the equations are only 2 and variables are 3. Okay, so there exists in linear, non-linear solution. It's linear independent solutions. Okay. Okay, so so you see that the rank of the matrix is 2. Number of variables are 3. Okay. The number of linear solutions are n minus r, that equal to 3 minus 2 equal to 1 linear independent solutions exist. Okay. So let us assume that linear solutions x3 independent solution equal to k. Okay. Let us assume that k. So substitute the second one. Minus 4x2 plus 4x3 equal to 0. That means minus x2 plus x3 equal to 0. Okay. Okay. 4 are cancelled. Okay. Substitute the value. Minus x2 plus k equal to 0. That means x2 equal to k. Okay. Okay. We get x2 equal to k. So again substitute the x2 value in the first equation. Okay. We have to get x1. That is 4x1 minus 2x2 equal to 0. Okay. 4x1 minus 4x1 minus 2k. Minus 2k equal to 0. After simplifying, minus 4x1 equal to 2k. 2 1s are 2 2s are. Therefore, x1 equal to minus k by 2. We get after simplification x1 equal to k by 2. So the variables, the values x1 equal to minus k by 2, x2 equal to k, x3 equal to also k. Okay. Therefore, to write the eigenvector of the given eigenvalue 9. Okay. So the eigenvector is x1, x2, x3. Okay. x1, x2, x3. Write down the values. X1 is minus k by 2. X2 is k. X3 is also k. Okay. So now I take common factor of k by 2 because the eigenvalues are not in fractions. Okay. Okay. Simply 2. K by 2 as if common factor in the vector. Okay. K by 2. That means minus 1 here, 2, 2. Okay. So the eigenvector is minus 1, 2, 2. Therefore, the eigenvector x3 equal to -1, 2, 2. Okay, these are the eigenvector x3 equal to -1, 2, 2. So the -1, 2, 2 are the eigenvector of the given eigenvalue lambda equal to 9. Okay, so this is the way to find the eigenvalues and eigenvectors of the given square matrix. Okay, okay, that's it. So today just introduction about eigenvalues and eigenvectors on how to find eigenvalues and eigenvectors. Okay, so in next class we have discussed Cayley-Hamilton theorem, and by using Cayley-Hamilton theorem find the inverse of the given matrix and powers of the matrix. Okay, so bye.